continue with this. I want to finish the story of exercise and diet and how to maintain a healthy skeleton. Bones, joints, get older. Are there any questions about what I talked about last time? Yeah. We did not, yeah. This one? Yeah, right. So I do Ashtanga yoga, and it's a type of a pretty vigorous type of yoga. And so when I talk about exercise, I tend to talk about it in yoga, but exercise can be a lot of different things, right? Weight-bearing exercise can be just barbells, body resistance. Or there's a lot of different types of weight. Ashtanga yoga is a type of. So the things I'm going to be talking about are related to weight bearing. It doesn't have to be you like getting ripped in the gym with metal, but you can do that if you want. All right, so we know that bones recycle, right? They dissolve calcium away, they build calcium up, and there's this like 1/5 of the mass of a bone every year is turning over. We know that bones are somehow responsive to the way that we use them. And if you have a heavily stressed bone, a bone that is being used and bearing weight consistently, then it's going to become stronger. It's going to respond to that. And we're going to find out what the mechanism of that is in a little bit so that it's not just magic. One good way to achieve this is through regular exercise, such as yoga. Yoga is a great way to not only build bone density, but it reduces stress and a whole host of inflammatory cytokines, basically blood chemistry, inflammatory rather than pro-inflammatory. These hormones that lead to down. And it's these inflammatory hormones that can mess with bone regeneration. So if I go back here, these cells here, these are called T cells. It's a type of white blood cell that responds to these inflammatory hormones, and they interact with the osteoclasts and the osteoclasts in your body. So beyond that, yoga and properly practiced other forms of weight-bearing exercise. Osteoblasts build, and osteoclast corrode. Yep. Build. So it gives you correct postural health for ideal alignment. This is so important. This is important. So having, like, really paying attention to your posture is like very important, because the choices that you make now, if you get habituated to poor postural habits, then that does have a chronic effect. Soft, right? Your body was built to have a certain, and if you're not cognizant of that, then it leads to all kinds of problems. You have people with herniated discs or bulging discs or radiculopathy, fibromyalgia, the ability to lift your arm up your head. That kind of, it's pretty easy to do. For example, a lot of people's heads are tilted forward. A lot of people, I've done it myself. I have pathology of my own now. So, for example, sitting in a chair, you're sitting in a chair, kicking back like this, the alignment in the neck can lead to real damage in the discs. And with time, those herniated discs, those discs, intervertebral discs, begin to bulge out and they compress nerves, they compress the spinal cord, and they lead to pinching, they lead to numbness, tingling, weakness, a loss of motion, loss of. So, learning how to use your body correctly. I know, at least in the trig class, they laugh at me instead of like me writing on the board like this. I often will write like this because I'm trying to be aware. I mean, it's fine. I laugh at. Use my own absurdity. You laugh, that's good. But you know what I'm saying? Like, not. No.
Yeah, like just laugh.
Yeah. But do yoga. You can do it too then. Yeah, so anyways, all of this sort of weight-bearing exercise is going to prevent skeletal collapse and spinal compression. Yeah.
So, like, you said that, like,
yeah. Poor choices, yes.
Right. So
too much rock.
When we be at, I mean, there's like we can prevent it getting worse. At this, you know, because there's a certain amount that's like reversible.
You're pretty resilient, first of all. So at this point in your life, it's more about setting the correct habits and training the muscles of your body to respond and hold your body the right way so that chronic damage does not happen, first of all. Secondly, if there is any sort of minor deleterious effects on your soft tissue because of posture, at this point in your age, that can be remediated. So one of the themes that I haven't really struck here yet, I usually save it for when I talk about cartilage. But bone is highly vascular. Bone turns over. You break a bone, you heal a bone because there's so much. Cartilage is avascular. There's no blood. In fact, excluded. The way cartilage looks, it's much like, so here might be a chunk of cartilage. It is much like a sponge, right? There's these little holes in the sponge, and all this material over here, all this stuff, is the matrix of cartilage, just like the matrix of bone, except it's not calcium. It's like that osteoid. There's a lot of collagen, a lot of glycosaminoglycans, glycoprotein, all that stuff that I was talking about, all those organic molecules. It's really flexible. So, for example, your ear, this part of your ear, that's cartilage. There's different types of cartilage. This is one type of cartilage. Yeah, this part of your nose, exactly. It's cartilage here. And inside the little holes in the sponge are the chondrocytes. And for those chondrocytes to get the nutrients they need, the metabolic exchange, removing waste, getting fluid, getting nutrients, to be able to heal and repair cartilage, cartilage needs, just like a sponge. You take a sponge, you're going to wipe up the counter, you take it, you put it under the sink, get water in it, squeeze it out, and then release it in the water, and it soaks up water, and squeeze it out. Cartilage needs this sort of pumping action. So it's really easy to compress cartilage when you're standing, all those intervertebral compressed, but it also needs extension. So, for example, like inverted passive inversions where you are lengthening through the spine, that's putting a little bit of gentle cartilage, or even when you're just laying down when you go to bed, that's relieving that compression and allowing fluid to go into the cartilage. When you're doing, so again, for example, in yoga, there's different poses where you're doing these different types of forward bends, forward and back, pressing gently and then bending. It's this like pumping that helps the cartilage get that nutrient. The point is that you can change slowly with time. If you have problems with your discs, you can remediate them. A lot of people have this sort of posterior herniation, vertebral canal in the neck, because the vertebra look like this. And there are these discs in here like this, and the spinal cord goes down here this way. People, and this is anterior, this is posterior, people who bend their head forward, these discs, the vertebral bodies get like this, and these discs herniate backwards into the space where the vertebral canal, where the spinal cord travels, and it begins to pinch on that. If this is the problem that you have, you can learn how to remediate that by doing exercises and different therapies. So, for example, if that's the thing that you are dealing with, you can take your head and then pull it backwards, like on the axis, and look backwards. This is the kind of physical therapy you would do, where you're aligning the discs like this, the vertebra like this, and you're pushing those discs in the opposite direction. How to do that in such a way where you're not pinching off the disc there, because that'll make it worse. But so this is to say that if there are things that you have done to your body can should completely hard, but you do have to be very mindful. It's very difficult to regenerate yourself. So, but what I wanted to talk about here was the mechanism behind how bones respond to this exercise. Why do bones get thicker? You exercise and put weight. Pretty amazing. It's pretty cool. They did not understand this when I was your age. So this is something that has happened in the last. But so the idea is that when collagen molecules are stressed, they reveal these charges. You can imagine collagen. So each of these three colored strands here is a protein chain. All right, we talked about amino acids link up and form these peptides via the peptide bond, make these long chains. One of these cords here would be like a spiral of amino acids. It would be a spiral of amino acids and what's called an alpha helix. We didn't really talk about that, but and then three of them get spun together. It's much like a rope that you would use, a hawser rope that you would use to tie a big ship to a dock. Those big stranded ropes. If you've ever taken one of those stranded ropes, but if you take the rope and you push it together, instead of like pulling it, if you push the rope together, you can see that the strands kind of come apart from one another. So that's what happens here in your bone. You can imagine that this collagen is lying along the axis of the weight, the compression. Maybe the bone is running this way, and you compress the collagen, and by doing that the strands untwist just a little bit and reveal these charges that are on the inside, that are hidden on the inside of this strand of collagen. These charges are there to hold the protein together. Again, I did not, you guys balked when I was trying to go through the protein structure chapter, but it's just this idea that a protein structure is held together by a number of forces. Some of them are electrostatic charge forces, and when you compress collagen, these charges get revealed. All right. So what does that mean? Well, it turns out that these osteoblasts are attracted to charges. They are attracted to it. All right. An electric charge is just, it's like it creates an electric field. It creates an electric field, sort of like how two magnets approach each other from a distance. They can sense each other through space. Electric fields work through space, right? And these osteoblasts are drawn to them. And exactly why, I'm not going to go into the depths of that because I'll lose everybody. But it's when collagen gets stressed, it draws osteoblasts to them. Collagen gets stressed, reveals these charges. Charges draw osteoblasts, and then the osteoblasts begin to lay down matrix, and they transition to osteocytes and begin to lay down the hydroxyapatite. They begin to mineralize. They calcify the collagen, the matrix that's there, the osteo. All right. So it increases bone density. So take home here, bone compression causes increased bone density. Bone compression elicits these electric fields which attract osteoblasts, and they lay down. Yeah. Well, I mean, it's a good thing because that bone has been stressed along that line of force. You want the bone to be strong along that line of force, and the bone responds to that force and lays down more hydroxyapatite, makes it strong along that axis, right? So you have a limited amount of resource, a limited amount of calcium, and you're using it where it's needed. And this is how the body responds to the. Yeah. What? The heavy thing. Yeah. Electric fields, bones are all glowing. They're dancing. I know. It's amazing how many different gifts are out there. The real golden age of gifts. Are there questions on that? All right. So, the first person to really discover this was this dude, Julius Wolff. Julius Wolff. He didn't understand electric fields. He didn't know anything about osteocytes or cells in your bone. He did not understand that. But he did understand by taking very careful cross sections and mapping out the lines of bone as they were getting laid down. So here's a cross section of a bone, and he would make, these are actually drawings that he made, and he could see the lines of force. He mapped out the lines of force in the bone and said, well. He also made careful study of people's usage of bone, like how they in animals and in how a bone was being used. Was it being stressed? Was it bearing weight? And how that was reflected pattern of calcification that he was able to. So, yeah, it led to Wolff's Law, which was established 130 years ago. That's incredible to me that it was someone that long function of bone. It's basically bone is reshaped in response to the forces acting on it. I wish I could tell you more about this guy.
Like, see,
Absolutely.
That's so cool.
Yeah, absolutely. If you, for example, you take the skeleton of a bodybuilder, you are going to see in their radial tuberosity, in the radial bone, they're going to have like a larger bump than an average person would have, where their bicipital tendon, where the tendon of their bicep attaches, right? So the tendon will have pulled on the bone, and so it's going to have a bigger tuberosity, a bigger projection where those muscles attach to it, or maybe it'll be denser there, for example. Yeah, you can tell a huge amount about what a person did in their life by knowing what you're looking at. You're looking at like the microstructure.
Dinosaur.
Yeah. That's how they don't have any pictures of dinosaurs, right? Like, there's no photographs of dinosaurs. There's no like dinosaur frozen in the ice. There's bones, and by knowing what like, oh, this bone is shaped like this means there must have been a muscle group pulling off the bone. This way, they can reconstruct what the muscle groups of dinosaurs must have looked like, right? So that just by understanding the way bones respond to forces placed upon them, they're able to, infer what the structure of it. Only recently have they come to believe that a lot of dinosaurs must have had much more vivid coloration. Like, normally we just like draw them, but there's like indications by them like analyzing the genome of a lot of these dinosaurs that vivid coloration, striping pattern. Dinosaurs don't have lizard fur, true hair, limited to them. Yeah, they could have had feathers. Some of them, like certainly scales, what gave rise. I'm not a paleontologist.
So they just don't know.
I really don't. But yeah, I think you're interested. All right. Okay, so that's the main concept. Now I'm just going to. I guess I'm preaching here a little bit. I'm going to go through this paper. This is a paper that was published 3 years ago, and it was looking at the effect of yoga. Again, I guess I'm preaching yoga, but you can do a lot of different. I was looking at the effects of yoga on the loss of bone, on osteoporosis, loss of bone. So what we're going to do, I'm going to go through this a little bit with you, and for two reasons. One, to help you understand the importance of weight-bearing exercise and how that can potentially affect osteoporosis, and two, so that you can see what a science paper is. You can get a little bit of a practice in general, just looking at data, knowing what we're looking at, how to interpret. Because when you guys do whatever your project is going to be this spring, you're going to have to look at some papers, go science literature, to have some basic skill in how a science. So, anyways, there was this paper that happened. I think it was actually by a group of Chinese scientists. I'm not sure. But topics in geriatric rehabilitation, volume 32, number 2, 81, page 81 to 87, etc. So what was the objective? The objective of the paper was to assess the effectiveness of selective yoga postures in raising the bone mineral density. So looking at how dense a bone is in relationship, if there's a correlation with yoga. Methods, how did they do this? Well, it was a 10-year study, pretty long study, of 741 people that they recruited over the internet. They found people on the internet, asked them if they wanted to be part of the study, said, oh, we will put money, we do some yoga, we do your bone density. Volunteers comparing pre-yoga bone mass density changes with post-yoga bone mass density. And so they had bone scans 4 years before the yoga and for 2 years following. And then what did they measure? The outcome measures. So they took this X-ray scan of their skeleton to see what the bone density was. All right, and some MRIs of it as well. So I guess to go back, the areas that they were testing were the spinal bone density, the pelvis, and then the heads of the femurs. Because these are the 3 areas of bones in your body that are particularly susceptible to osteoporosis and osteoporotic, right? It's your spine, which leads to like classic grandma pose, and hips. People like grandma falls and busts her hip all the time. Like that's really easy. We talked about orthostatic blood pressure, right? How receptors in the neck, laying down, your heart is slow, get up, the blood drains from your head, starting fast. Pass out. Let's gas. The arteries up there. She gets up, she's all dizzy, whoa, falls over, busts her hip because her hip is not got the bone density. Hip fractures are very common, as are, breaking your femur, the head of your femur. It's another very common place. Yes, sir.
What makes those?
Well, I mean, this is like the primary axis of weight bearing, right? The spine, like all of this weight is coming down, right? It has to like translate from here through here into there, right? And this is pretty well stacked, right? This is like very well stacked. The architecture of this is pretty straightforward. Like the point load goes right down through, it's like a column that's stacked. This is not a column that's stacked, right? It translates obliquely, like at an angle. You see that?
Yeah.
And then also the musculature that's around here, people don't, this is like core muscles, like that is supporting this whole area. These are a lot of muscles that people don't consistently work. People work their like biceps. People like to do that. People or like arms, shoulders, back a little bit, but like this is like your core muscle and muscles around the pelvic girdle, hip flexors, abductors and adductors of the hip extensors. People aren't really strengthening that stuff. Core muscles right around here. So there's not a lot of the like muscular contraction that's leading to weight bearing and bone density increase. But fortunately, yoga is doing all kinds of things in that area. So they're trying to see what's up. These are the poses that they have. 12 of them. I don't know if has anyone ever done yoga in this room before? A few of you guys. Cool. Most of you. Wonderful. So there's tree pose. This thing. Triangle pose, Trikonasana. Warrior 2, extended warrior, side angle warrior, reverse triangle, that locust pose, bridge pose. I don't know all of these here. Marichyasana A and B, and then Shavasana. Pretty basic yoga sequence here. We could run through this as a class. And they say 12 minutes. Yeah, we could do it in 12 minutes. Pose. Yeah, Shavasana. No, that's not that hard. It's not that hard. It just looks gnarly. I mean,
oh yeah.
It's just this. I'm not warmed up right now. This is all that.
Yeah.
And the way that
if I was
her head too, it makes
That's weird.
No, it just goes back around. Yeah. If you did yoga twice a week for a month, I'd get you. It's not that poses. Loosen it up. Anyways, so that's what they're doing. Honestly, I would have picked some different poses. Some of these are good. Yeah, that's good. This is certainly good. This is good. That's good. Bridge pose is good. This is stretching. There's no strengthening here. This is good. There's no real strengthening here either. This is stretching. This is none of these actually involve any strength building. So I don't know how effective this is going to be, but we'll see. We'll see. All right. So here's the data. This is the change in spinal density. All right. So the y-axis is is bone density. Pardon me. Before and after in the spine, the hips, and the femur. All right. So before and after in spine, hips, and femur, bone density. And what you see here, this bar would be, this is the average, and this whisker here, this is called a whisker, that is the uncertainty in the number. That's like the error, how uncertain. So they're saying with 95, it's called the 95% confidence interval. I know that I can say that this is the average value across 741 people. And that value is, with 95% confidence, I can say that it's somewhere in this range. That was the actual value that we got, but there's a lot of spread in the data, and so given the sample size, I know for 95% certain that it is somewhere in those ranges. All right? Yeah, not very accurate. Yeah. So the question is, which of these results show a positive correlation between bone density and yoga practice? Positive correlation, so before and after. Which of these before and afters is a positive correlation between doing yoga and an increase in bone density? So he says B and C. So Lance says A and C. Are there any others? It can be none of them if you think none of them show a positive correlation between exercise and bone density. Yeah, Aaron. What's that? So A, B, and C. All right. And anybody else? Anything different?
Well, okay, because B, like, if you go by what they exactly had there. Sarah.
Okay, so you're going with Lance. How many people are with Lance? So we're trying to fit. I'm asking you. A positive correlation means so there's a positive correlation between my mood and access to delicious. So like
Mood
oatmeal
increases,
raisin
the more
cookies,
oatmeal raisin
the more my mood goes. Or yeah. So for which of these is there a positive correlation? Well, that's what I'm trying to get you to look at here to understand. So this error range is 95. This value, I'm 95% certain that it's somewhere in this range. This value is actually somewhere in here. The numeric mean that we came up with was this, but maybe if we instead of 700 we sampled 7,000 people or 7 million people, the actual value would be right here, right? And if we did the same 7 million people, this value may be down here. It's with 95% certain that the actual value, this is the mean that we got given our sample size, we are 95% certain that the actual value is somewhere in this.
Yeah, so A and C don't even like touch. Like they don't even touch each other. So there's like no way that A and C could not be. Because the margin of error is like literally away. But with hips, there is a way that it's negative.
Okay, is anybody going to stand up and defend Aaron at all? Lonely man. Yeah, that's correct. That's the right way to interpret this. It's A and C, yeah, because their ranges don't overlap at all. So we can be 95% certain that these numbers are definitely different. We don't know that these two numbers are different. There's like they probably are, maybe a little bit. What it probably says is that they weren't doing exercises that actually impacted the hips. But it definitely impacted the spine and femur. All right. Which of these three areas demonstrated the strongest correlation? Which of them had the strongest correlation? So let's see here. Yeah, we have different scales. That's right. You got to look at the scale.
The spine.
Does everybody see that?
Because they're both the bottom number.
So the difference here is 0.0018, whereas the difference here is 0.00085. So this is roughly twice as strong of a. Just a little bit of a opportunity to look at data and understand what data is telling. All right, another one. Are there any negative or inconclusive correlations? This is simple, but yeah. Hips. Hips is inconclusive. Are there any negative correlations? No. Yeah, it's an inconclusive correlation. All right, so that was the paper. Beyond learning how to read data, one of the points I'm making here is that there is, not only did I give you a mechanism for how this works, there's been experimental data that shows that, for example, yoga, certain types of yoga are going to be able to affect your bone density. And it actually, this mechanism works in practice. So it's not just exercise, though. It's nutrition as well. What do you eat? So we need to have. You can't have bone growth without having calcium and phosphate that is passing through your system. Yes, sir.
Earlier, how is it negative?
Where?
There's negative. Does it just mean that it went down, or does it mean that it's like you have negative?
So the way this worked was it was a 10-year study, and in 1, 2, 3, 4, 5, 6, 7, 8, 10. And I like that you're asking this question. It's good that you're thinking deeply about it. So at year 1, they did a scan, right? Scans. And then that continued. They did this for every year, all right, for the first 4 years, all right? And then they did 4 years of yoga, all right? And then they did 2 years of scans, all right? And so in that first 4 years, the first year, they started at 0. That was their baseline. And then after no yoga for 4 years, they saw a decline in bone density. Their bone density went down. These people had no exercise for 4 years. Their bone density went down. Then they did yoga for 4 years, and their bone density not just went back to normal, but exceeded their baseline by the time they took the scans over here. Does that make sense?
Yeah.
So this is showing that bone density went down in their spine, and it went down dramatically in their femur. In their hips, it's hard to know because this 95% confidence interval is on either side of the 0. Make sense?
Yeah.
Good question. That was a good question. Oh, wait. This class go to 12:20. All right. You also need like magnesium, fluoride, iron, and manganese. These other trace minerals in your diet. Oh, hello. Piano lab. Hi. Your presence is requested. No, you'll be fine. You seem very happy. All right. So where do you get all of these things? Well, here are some examples. If only the school lunch looked like this. We have kidney beans. We have kale. We have some bunch of dairy. It's a great source of calcium. We have lentils. We have spinach. We have sardines, cold water oily fish. I don't know who likes. I like that. Broccoli. Yeah, these are chickpeas. What is that? Oh, those are figs. Figs. Yeah, figs are high in. Figs are high in all of those minerals as well. So those are all good foods to eat. So you don't have to be taking like the Geritol pills and pissing most of those vitamins out the waste. Eat delicious, healthy foods. Scribble, scribble. Okay. And so it's not just the minerals. You need vitamins as well. Again, I sort of skipped over a lot of the basic biochemistry beginning, so you never heard me talk about the difference between a vitamin and a mineral. But a mineral is one of those elements that I described. But a vitamin is an organic molecule, meaning a carbon-containing molecule that acts as a cofactor to some protein that's doing something in your body. All right. So the proteins that those osteoblasts and osteoclasts are making, which are going through the process of building bone and dissolving bone, those proteins, they need cofactors, like little keys to turn them on. It's like your snowblower. You need a little plastic key to turn that thing on and make it do what it's going to do. The vitamins that are specifically required for bone health are vitamins A, C, and K. So vitamin C is a water-soluble vitamin, so you need a consistent source of vitamin C. Vitamins A and K and B12, these are, well, B12 is a water-soluble, but A and K are both fat-soluble vitamins. So you can store those. Vitamin C is necessary for collagen. I have like a whole lecture about vitamin C. But vitamin C, the lack of vitamin C is what leads to what disease? Scurvy! Scurvy. So fun. Scurvy is actually horrible. But has anyone ever seen a picture of someone with scurvy? Yeah. Scurvy, their gums start to bleed, their teeth fall out, their skin, they get lesions all over their skin. It's pretty nasty. You don't have vitamin C. Because you need vitamin C to make collagen. And collagen is, you can think of collagen as like the ropes that hold your body together, right? There's, I don't know, like 20 different collagen genes in your body, 20 different types of collagen that your body makes in different places. And one of the important places that collagen is made is in your skin.
So that's why, like,
yeah, yep, yeah, because they're not making collagen. Anyways, you need vitamin C to make collagen. We've already established how important collagen is. And then vitamin C also stimulates the osteoblasts to become osteocytes. All right, so it's necessary. Vitamin C is necessary for that transition, as is vitamin A. And then vitamins K and B12, the cells need those vitamins to be, the bone cells need those proteins need to make to do the jobs that they do. Vitamin C is all over the place. You can get it in orange, any kind of citrus fruit. Like most fruit has vitamin C. Potatoes, surprisingly, have an amount of vitamin C in them. It's like anyone ever made potato clocks, batteries. It's because there's vitamin C. Anyways, yeah, vitamin C. Vitamin A, also known as beta carotene. You can get beta carotene in any of your orange vegetables, often as well, but there's a huge amount of it in carrots. So eating carrot a day or carrot a day is a reasonable source of vitamin A. Has anyone ever heard of golden berries before? You go to Hannaford's, the fruit section, there's like a weird fruit section. They have these little packages. You should bring them in someday. They have there's these fruit called golden berries. They are small, like that, but great. They're golden. Try eating one. Really delicious, but they are the highest concentrated source of vitamin that that you get. They're pretty intense. Yeah. Golden. Vitamins K and B12. So vitamin K comes from a lot of green fruits there. So green apples, kiwi, broccoli, kale, scallions, grapes, all of those things have vitamin K. Vitamin B12, any of the B complex vitamins are going to be found in fish, poultry, red meat, good sources of vitamin B, of vitamin B12. Are there vegetarians? Yeah.
Oh, okay. When you, I don't.
It can. Yes, it can. Absolutely, it can. Some vitamins are more resistant to that than others, but uh, in general, it's better to eat a food closer to raw than closer to overcooked. But some foods are difficult to absorb the like fully absorb the vitamins if they're not like a little bit. So yeah, like lightly cooked always makes a vegetable. All right. So what this looks like a take-home slide. Osteoporosis prevention, exercise and diet, ages 25 to 40 is crucial. Is that if I impress that upon you? So learning how to incorporate that successfully into your life, into your daily life, like making positive choices about the foods you eat, making positive choices about your physical activity. I know that can be hard, particularly if you live in a house where that is not part of the daily culture of your family, but it can be healthy food and bad. And you certainly have power to make choices about the types of exercise that you do. Learning to be mindful about these things is something that your adult self will think. Your adult self will be so thankful that you learned how to be health positive. You can still have a bohemian lifestyle, go off and do whatever weird thing you want, but just be mindful of how you nourish and feed your body, because frankly, we're just inhabiting this body. We get to live in this good